Hello, this is Mr.Morin, and today I'm going to make a video talking about naming ionic compounds. We're going to make a couple of videos about how to name different types of compounds. Our first one is going to be ionic compounds. Another term you may hear is nomenclature. Nomenclature is just the word that we use to talk about how do we name chemicals. So naming chemicals is a really big part of chemistry. It's almost like learning a second language. So these videos are going to be helpful, I hope. And let's get into the first one. So each different type of compound is going to have different rules for it. So when we're looking at naming something, the most important thing you need to do is identify whether it's ionic or covalent or an acid or a base so that we can apply the right set of rules. So if I'm naming something that's ionic, we need to understand what does it mean to be an ionic compound. So an ionic compound means that we're going to have a metal and a non-metal. Okay, so if I look at my periodic table, we separate our metals and non-metals with this little stair step right here. Our non-metals are going to be in the top right part of the periodic table. The rest of the periodic table is going to be metals. Okay, now this is kind of a little bit of a cheap way to determine if it's ionic. Truly what we're looking at is a difference in electronegativity. If there's a large enough difference in how well these atoms pull on electrons, then they're going to form an ionic bond, where the positive, or typically the metal atom, is going to take the electrons from the non-metal, and then we're going to form two ions. So a better way to say this is, instead of a metal and a non-metal, is that we're going to have a positive ion and a negative ion. Now these don't have to simply be atoms. If it's just an atom or an element off the periodic table, we would call that a monatomic ion. For example, if I had a lithium ion that's +1, and I had a chlorine ion that's -1, these things could come together and form LiCl, lithium chloride. Those would be monatomic ions. But we also have what we call polyatomic ions. So if we look at polyatomic ions, these are still going to act the same way. We don't have very many examples of positive polyatomic ions. Ammonium is a really good example. But we do have a whole bunch of negative polyatomic ions. So most of the time you'll hear teachers say it's a metal plus a non-metal. A better idea would be to think it's a positive ion and a negative ion. In terms of the periodic table, metals are going to be positive ions, non-metals are going to be negative, but we do see these polyatomic ions popping up. It would be a good idea to start memorizing some of these. Depending on which chemistry course you're taking, your teacher may ask you to memorize more or less of these polyatomic ions. So how do we name these? Okay, we learned how to recognize them. If we have a metal and a non-metal, or if we have a positive and negative ion, it's going to be ionic. And we have a set of rules to name these. And it's not too bad. Okay, so what we're going to do, we're going to just name both ions, and we're going to change the ending of monatomic negative ions to "-ide". We're going to leave the ending of polyatomics negative ions alone. For example, if I had sodium and chlorine, these are both monatomic ions. I have a metal, sodium, right here. I have a non-metal, chlorine, right here. And these things are obviously ionic because we have a positive and negative ion. So if I wanted to name both of those, I would name both ions, but I would change the ending to "-ide" for my negative ion. So this would simply be sodium And then for chlorine, we're going to call it chloride. One point of confusion for students is which part of the word do I replace with "ide"? So for something like chlorine, we're going to change the last little part to "ide." For something like sulfur, instead of calling it sulfuride, we're going to call it sulfide. For something like phosphorus, instead of phosphoride, it's just phosphide. So knowing when or what part of these words to change to IDE can be a little bit confusing. There's not really a set rule, but once you start seeing some of these, it's going to be obvious the right and wrong way to say that. So you'll just have to kind of get used to that by experience. We do have a few hiccups in this though. When I'm looking at my metals, if I look at my metals on the periodic table, these first two groups we know are going to be +1 and +2. We do have some confusion though when we look at our transition metals. These can have more than one charge. It depends on the situation. For something like iron, this thing could be +2, +3. It's really hard to know without a little more information. Some of these only have one option. For something like zinc, it's going to be +2 every time. For something like silver, it should be +1. But for copper, it could be 1 or 2. So depending on if you're in AP chemistry or accelerated chemistry or chemistry 1, you may or may not be expected to memorize a few of these that only have one option. But we need a way to explain which one we're talking about, because if I had a chemical like iron oxide, if I wanted to try to take the name of this and write my compound, a student may look at this and say, well, iron is Fe, oxygen is O, but is this correct? Okay? When we're going from the name of a compound to the actual formula, we have to consider charge. Charge is a big deal for ionic compounds. When these ions are coming together, when my positive and negative ions come together, they have to balance out their charge. For my example up here with lithium, this was +1, chlorine was -1, so we get LiCl. But if I had another example, let's say we had sodium, which is +1, and sulfur, which is a -2 charge. When these come together, I need them to add up to 0. I need all the positive and all the negative to balance out. So I would need twice as much of my sodium for each sulfur, because this is only +1, this is -2, so I would end up with a compound like this. And we show that with subscripts. So I need 2 sodiums for every sulfur. When I look at iron oxide, I don't know what the charge of iron is. If I just see iron and it's down here in the periodic table, I don't know what that charge is. So I don't know how many oxygens I need to put with it. I know for oxygen, like we see here, everything in that group is going to be -2 when it bonds. So my iron is a little confusing, but my oxygen is -2. So when we have transition metals, we need a way to show the charge of the transition metals in the name. Okay, we're going to do that one of 2 ways. There's an older system that applies different names to these compounds. For example, for iron, if you look at its symbol, it's Fe. So they would use the old name ferrous, and they could either call it ferric or ferrous, depending on the charge. That system is very cumbersome and confusing, so we're going to use a different system. We're going to use Roman numerals to identify the charge of these metals. So if instead of writing iron oxide, if we wrote iron 2 oxide, well, this 2 tells us the charge of the metal. So anytime we have a transition metal, we have to have a Roman numeral. That Roman numeral tells us the charge of the metal. Now, this is a very important point. It does not tell us how many of anything we have. It's not saying I have 2 irons or 2 oxygens. It's simply telling me that iron is +2. So whenever I'm going from the name of a compound to the formula, I simply write each ion below so that I can see their charge. How do I know this is a 2? Because it says 2. Oxide is oxygen, and I know that the charge of oxygen is -2 because of the group it's in. So I would put oxygen with a -2. Once you know the charge of each ion, we're going to combine them in the lowest possible ratio for their charges to balance out. Now this one's pretty simple. If it's +2 and -2, if I put one of each of those together, they're going to balance out. So I would have FeO. Okay, so let's look at another type of iron oxide. If we had, for example, iron 3 oxide, again, that 3 is telling us the charge of iron. So we would say that iron has a 3 positive charge, oxygen has a -2 charge. Now when I look at these, I need to think, well, what's the lowest ratio of both of these that would get them to balance out? And what we're really looking at is something called the lowest common denominator. What's the lowest number that 3 and 2 are both a factor of? And that would be 6. 6 is the smallest number that those are both a factor of. So what we need to think about is we're going to need +6 charge and -6 charge. So how many irons does it take to get to +6? Well, if I had 2 of them times a +3 charge, that would give me +6. How many oxygens would it take to get to -6? Well, if I have 3 of those, that would give me a -6. So what this is saying is that I need 2 irons and 3 oxygens. So this would have an overall +6 and -6. So together they balance out. Without knowing this number, we would have no way of figuring this out. So when do we use Roman numerals? We use Roman numerals when we have a transition metal. We don't need them on the first 2 groups because I know exactly what their charge is already. We also don't need them if it's a particular element that we know the charge of already. Silver is always +1. Zinc is always +2. So a lot of times you'll see the Roman numerals left off of those, but it's kind of up to the teacher to determine, are you going to need to memorize which ones have a +1 charge every time? For me personally, with the Chemistry 2 students or Chemistry 1 students, I would not have a big issue if they were to put silver +1 instead of just leaving it off. The other thing we talked about are the polyatomic ions. So let's look at an example of something that has a polyatomic ion. So let's say we had NaNO3. So if I want to name a compound, the first thing I need to do is identify what type is it. Here I have sodium, which is a metal, and then some other stuff. If it's an ionic compound, it only has 2 parts, a positive and a negative ion. If it was covalent, then we wouldn't have metals or nonmetals. We wouldn't have polyatomic ions. So by seeing this sodium, I know that this is ionic. I have a sodium and I have this other stuff. Because there are more than 2 elements, I know there has to be some polyatomic ion. So these are my 2 parts. Na is Na plus. How do I know it's +1? Because if I look at the periodic table, it has a +1 charge. NO3 is a polyatomic ion. If I find it right here, I know that NO3 is called nitrate, and it has a -1 charge. So we have NO3 with a -1 charge. So I've identified both of my ions. Now I just need to name them. Na plus is called sodium. I do not need a Roman numeral because sodium is not a transition metal. It's right here in my first two groups. And this is called nitrate. And that's it. Sodium nitrate. Notice, I did not change the ending of that to "ide." We only change the ending to "ide" whenever it's a monatomic negative ion, meaning it's an element off the periodic table. Then we would change to "ide." If it's a polyatomic, we leave it alone. We have to leave it alone because you may notice many of these have different endings. We have nitrate and nitrite. We need a way to tell which one are we talking about. And we do that with this suffix at the end. The ate or the ite tells us which one we're talking about. Both of these have a -1 charge, but if I have an ate or an ite, they have different numbers of oxygens. Okay, so there's basically two different things. We could ask you to go from the formula to the name, or we could ask you to go from the name to the formula. Personally, I think it's easier to go from the formula to the name, but you kind of have a different approach. You're doing it backwards one way or the other. If you're going from the name to the formula, you really need to pay more attention to charge. So, for example, if I had something like magnesium bromide, and I wanted to write the formula, I know this is ionic because magnesium is a metal. Bromide, this "ide," tells me it's monatomic, meaning it's just bromine. If this ended with an ate or an ite, then it would be a polyatomic ion, but because it has "ide," I know it's just bromine. I know it's ionic because I have a metal and a nonmetal, and I need to figure out the charge of both of these. So I would look at my periodic table. Magnesium is right here, so it's +2. It's not a transition metal. I know it's not a transition metal because there's no Roman numeral. So I would say Mg with a +2 charge. Bromide means we have just bromine, and it's in this group here. It's a halogen, so it's -1. So now we look at our charges. If this is +2 and this is -1, I'm going to need 2 bromines to balance out my magnesium. Now, some teachers may show you this little trick where you can take the charge and cross the charges, and that will tell you how many of each one. All you need to be careful of with that is that once you do that, you've reduced it to its lowest whole number ratio. So if I have a 1 and a 2, that's already the lowest ratio I can get. So we're saying I need 2 bromines for every 1 magnesium. This is -1 and +2. So if I have 2 of the bromines, overall it balances out to 0. Let's look at one where we're going from the formula to the name. If I were to look at something like Cu2O, okay, I look at this first element and I have copper. I look at the next one and I have oxygen. So I know I have copper is a transition metal, oxygen is a nonmetal. I have a metal and a nonmetal. So I know I have an ionic compound. So what I need to do is figure out a few things. Do I need a Roman numeral? Well, yes, copper is a transition metal, so we need to identify its charge with a Roman numeral. And we don't have any polyatomic ions. So I know I'm going to need to change the ending of this to "ide," I-D-E. So I have copper. It needs a Roman numeral, so I'm just going to put a spot for that. And then oxide. So how do I know what Roman numeral to use? Well, I need to figure out the charge of copper. I don't know the charge of copper. It's a transition metal. So how would I figure out the charge of this transition metal? We do that by looking at what it's bonded to. I have 1 oxygen. Oxygen's charge is -2, and there's only 1 of them. So overall, this is -2, which means my positive contribution has to be +2. I don't know the charge of that, but I know there are 2 of them. So what number times 2 gives me 2? Well, that would be +1. So this copper is +1. When we're writing the Roman numeral, we don't use the overall charge of all the coppers. We use the charge of each copper. So each one of these coppers has to be +1, so that together they add up to +2. So this would be copper 1 oxide. So that's a very common mistake students make. You're not looking at the charge of all the coppers. You don't want to use all of them combined. You want each individual copper. Together, they added up to +2, but individually, they were just +1. Okay, let's look at a couple more examples. So let's say we had something like, calcium nitrite. So if I look at a compound like calcium nitrite, I know it's a ionic compound because calcium is a metal, and then I look at nitrite. The ending is really important. Ite is not going to tell me that I have a monatomic ion. If it was just nitrogen, it would be ide, I-D-E. This is I-T-E. Anytime you have an ate or ite, that tells us we have a polyatomic ion. So if I look here at nitrite, it's NO2 with a -1 charge. So if I'm going from the name to the formula, I would want to look at their charges. Calcium is +2. I don't need a Roman numeral because it's not a transition metal, so this calcium has a +2 charge. Nitrite is -1, and the formula for it is NO2. And it has a -1 charge. The polyatomic ions can cause confusion. You want to think of these like units. Don't think of this as a nitrogen and 2 oxygens. Think of this as one thing, and that thing has a -1 charge. So whenever I go to combine these, calcium is +2, nitrite is -1. So I need 2 of these to balance that out. So I have a calcium and a nitrite. How am I going to show I need 2 of these? We can't just stick a 2 here, because now that looks like a 22. It looks very confusing. The way we show polyatomics being multiplied or needing more than 1 is we put that whole polyatomic in parentheses and then show the quantity outside as a subscript. So this is saying I have 1 calcium and I have 2 of what's inside the parentheses. So 1 calcium and 2 nitrites, okay? So hopefully this video helped. We could do examples all day, but I think this video has been long enough. So if you have any questions, email your teacher. Hopefully this was helpful, and thank you.